Hey guys, welcome to Empty Stack and you are watching LeetCode series of problem solving using Java, and today we are going to look at letter combination of a phone number. To solve this question, it is good to have knowledge on string, backtracking and recursion. The difficulty level is medium and the question was asked in interviews of companies like Google, Facebook, Amazon, etc. Okay, let's jump into the question. So we are given a string that would contain digits from 2 to 9 and we need to return all possible combinations that the number could represent. For example, 2 represent ABC, 3 represent DEF and so on. Let's look at an example. Let's say the input is 2 and 6. Now 2 represent A, B and C and 6 represent M, N and O. If we talk about all possible letter combinations, it would be AM, AN, AO, BM, BN, BO, CM, CN and CO. Now all we need to do is return this list of the string and that would be it. So the problem statement is straightforward. Let's try to break down the solution. Let us take the same example 26. We start with 2. Now 2 could mean 3 letters A, B and C. Next what we have is 6. Now 6 represents 3 letters M, N and O. So after A, we can have M, N or O. Same goes for B and same goes for C. Now what we have is a sort of tree structure. Let's see how we can traverse over this and get all possible letter combinations. So the input is 26. We start from the first digit 2. Now 2 is mapped to 3 letters A, B and C. We go to the first letter A. Now we need to append the next letter from the next digit. So we go to 6. Now from 6 again we have 3 choices M, N and O. So we go to the first letter M. We again repeat the process and try to go to the next digit if there are any. There are no more digits, so we can say we have found our first letter combination. Now we go back. From M we go back to 6. Once we go back, we check for any other letter mapping for this number. So we see N and O are also there. So we go to N. Then we see if there are any other digits. There are no other digits in the input. So we have our second letter combination, that will be AN. Now we go back. We go back to 6. Once we go back, we check for any other letter mapping for this number. Now we go to O. We again check if there are any other digits. There are none. So we print AO. Then we go back to 6. Is there any other letter combination from 6? No. So we go back to A. Now from A we go back to 2. Now once we have reached 2, we have to repeat the same process for other legs of 2. So we see what other letters 2 is mapped to. We find it is mapped to B and C. So we go to B. Then we look for next digit after 2. That will be 6. So for 6 again we have M, N and O. So we traverse 6 and we go to the first letter M. Then we check for any other digits. There are none. So we print BM. Then we go back to 6. Then we go to other letters of 6. That will be N and O. And from here we will get BN. And then we go back and then we get BO. Then we again go back to 6 to B and then 2. And we look for any other letters mapped to 2. We find C. Then we repeat the process for C in the same way. And we get CM, CN and CO. Now we have found all possible letter combination for the digits 2, 6. And this will be our output. So what we have done just now is a very famous technique called backtracking. So if you are not familiar with the term or you are not sure on it, now you know it. To reiterate, backtracking is a brute force approach to search all possible combinations. If current solution is not suitable, we backtrack to search for other solutions. Or if we talk about this problem specifically, once we reach the leaf node, we backtrack to find other possible solutions. Let's try to build an algorithm for this. We start from some basics. We can see that the length of each combination is equal to the length of the digit which is provided to us. Secondly, if we look at the mapping between the numbers and the letters, we see that 1 and 0 is not mapped to anything. So we are only interested in numbers from 2 to 9. Then this mapping between these numbers and letters will always be a constant. So we can store them in a constant space like an array or a map. Next thing we understood that this is a backtracking problem, so more intuitive way to solve this question would be recursion. Okay, let's consider these points and try to form a basic algorithm. So our input function would look something like this. So we can start by defining n, which would be length of the digits, and the string combination that will store each combination once we find them. Next we can define the constant map we were talking about, and it will have all the mapping between the numbers and the letters. Now we can define the result list and the backtracking function, which will be called recursively. We'll see how it will work, but for now we'll just declare it and we return result. Let's see in detail how this backtracking function should work. We can start by declaring arguments to be passed to this backtracking function. So for sure we need the input string digits, so we will add it as an argument. In this case the value will be 26. Now we need to get the first digit 2 from this. So we will define a variable to store it. Now the index in first recursion should be 0, in the next one should be 1, and so on, because we want to iterate over the digits. So we can keep I as an argument too. And in our main function we'll hardcode this to 0 because we always want to start from the first digit. Now for this digit we need to find all mapping letters. So we can also pass our map as an argument to fetch all the letters. Next we want to iterate over these letters one by one, so we'll define a loop for this. Now in the first iteration we will have a. Now we want to append this a to our combination variable that we have defined before, so that it can be added later to the result list. So the combination variable should also be passed as an argument, and to this variable we append a. Now before going to b, we want to repeat the process for next digit, so that to a we can append m, n and o. So we'll call our backtracking function again for the next index. In this case it will be 6. So in argument we will copy everything as it is except the index, which will be increased by 1. For simplicity, let's visualize this recursive call separately. So this time I will be 1 and the combination string would be initialized with a. We get the digit using index as 6, letters as m and o. We iterate over these letters and we start by appending m. Now we again have a recursive call. So let's see the values passed this time. Now we have I equals to 2 and combination is am. We see that I is now equal to the length of the input number. As discussed, that also means we have our first combination ready. So we can add a base condition that when I is equal to n, we can add combination to the result list and return immediately from there. So to do this, we'll add result as well to the argument, and we can update the result list in our main function with am. Now we have returned from this recursive call and we reach inside the for loop for 6. We have to repeat the process for other letters of 6. But before doing so, we need to remove the appended letter m, because if we don't do that, the new combination would still have m and we don't want that to happen. So we will remove the last character from the combination string. Now here combination value will again become a. In the next iteration we will have n and combination string will become an. So same way, the next recursive call, we see length is same as length of input, so we can directly return from here and add an to the result. Now same thing will happen for AO as well. And we finally return from this recursive call. Now in the first recursion, we remove appended A from the combination string, and in the next iteration, we append back B and repeat the same recursive calls as before. And same as A, we will append BM to the result list, and same way it will happen for other combinations as well. So we can safely assume that our algorithm is fully ready now. Let's go over it once more. So we have a main function and a backtracking function. In the main function, we mainly start by initializing some variables like n for length of the input digits, combination for storing letter combination, a constant map, and a list to return result. We call backtracking function from here, which calls itself recursively. In this function, we have a base case to check if value of current index is same as that of length of the input digit. If so, we add a combination string to the result list and we return from there. If not so, we get letter mapping for current digit and iterate over each letter mapped to this digit. Now we append each letter at a time to the combination string. Call our backtracking function for the next index and remove the appended character. If we talk about complexity, we know that the for each loop would be called maximum of 4 times for digits 7 and 9 as they are mapped to PQRS and WXYZ. So this will be our worst case. Secondly, the recursion would happen n times, where n is the length of the input string. So our worst case complexity would be O4 to the power of n. Okay, let's look at the Java solution. Let's start by defining ArrayList to return the result and a map to store mapping between numbers and letters. We are using array, but we could also use a hash map. The first two elements are empty as no mapping are there for 0 and 1. Next, we define a string to store combination. We will use a string builder as it is faster to do string manipulation. Now we call our backtracking function and we return the result. Let's define the backtracking function. In the argument, we'll have input digits, the map, the index, the combination string, and the result list. Let's pass these values. Now first we write the base condition. If index is equal to length of the input digit, we add combination to the result list. Else we'll get letters using mapping for current digit. Input is a string, so we use caret. Since data type will be character, we minus 0 to get actual integer from the ASCII code. Now let's iterate over this. For each letter, we append it to combination string, call our backtracking function for the next index, and as discussed, we remove the last character after returning from the recursive call. Now let's define some edge cases. If digit is null or length is 0, we can directly return the empty list. Let's try to run this. Perfect. See you guys in the next one.